Now let's see what we have over here among these. Alright, now here you have a particular problem which says find the limit of the expression 1 upon x cube plus x square plus x plus 1 as x approaches infinity. So it is 1 upon x cube plus x square plus x plus 1 as x approaches infinity. So the biggest power among these is x cube. So we divide both numerator and denominator by x cube. So we get 1 upon x cube by x cube plus x square upon x cube plus x upon x cube plus 1 upon x cube. Hence you end up getting 1 upon x cube upon 1 plus 1 by x plus 1 by x square plus 1 upon x cube. Now this is a function. Now limit of this function as x tends to infinity will turn out to be, this turns out to be 0 upon 1, 1 by x is 0 plus 0 plus 0. So it is 0 by 1, which will be 0. Since the numerator is 0, the value of this expression, that is the limit of this function as x approaches infinity. Candidates have a tendency to skip this or miss this. So please see to it that what the variable is tending to. So that means limit of this function as x tends to infinity is 0. Right. Okay. Furthermore on this, so limit of 2x square plus 7x plus 5 divided by 4x square plus 3x minus 1 is equal to L, where L is what among these? Now again, we do the same thing. We have to see that all the x terms go to the denominator. So hence, divide both numerator and denominator by x square. So you get 2x square by x square plus 7x by x square plus 5 by x square upon 4x square by x square. Suppose the denominator had cube, then divide both numerator and denominator by cube. X square minus 1 upon x square. This turns out to be 2 plus 7 by x plus 5 by x square upon 4 plus 3 by x minus 1 by x square. Now you need to find limit of this function as x approaches infinity is equal to 2 would remain as it is. 1 by x, the limit would become 0. 5 by x square, limit becomes 0. Upon 4, 3 by x, the limit becomes 0 minus 0. So ultimately it's 2 by 4, which is half. So the limit is turning out to be half. So this is a practice we undertake in these kind of situations wherein we divide by the biggest power of x that is present in the expression. Okay. Now here we have a situation, limit as of root of three x raised to 4 plus 5x square plus 7x plus 5 divided by 4x square. This is what you have. Now, hence what do? We write this as, we'll take the whole thing. So this 4x square eventually will become 16x raised to 4. So you'll turn out to it turns out to be 4 can be, so hence 4 can be taken out in any case outside. So you get 3x raised to 4 by 4 is in any case outside. So we can write it as 4 and the remaining part can be taken inside. That is, we will actually have, let's simplify this. We can take 4, if the square root sign is only for the numerator, the denominator does not have it. So we can write this as 1 by 4. And now x square can be written as root of x raised to 4. Hence we write it as x raised to 4. 3x raised to 4 plus 5x square plus 7x plus 5. So what we have done is that the 4x square is not a square root number, it's just 4x square. So we take out 4 and x square is written as root x raised to 4, so that it can be taken inside the square root cloud. So this turns out to be 3x raised to 4 by x raised to 4, 3, plus 5x square by x raised to 4, 5 upon x square, plus 7x upon x raised to 4, that is 7 upon x cube, plus 5 upon x raised to 4, that is 5 upon x raised to 4 itself. Now we need to find the limit as x tends to infinity, which turns out to be 1 by 4 into 3 plus 0, because as x tends to infinity, 1 by x and all the powers of 1 by x tend to 0. So 0 plus 0. Ultimately, this will become root 3 upon 4. So that's how we get this. So we get this as root 3 by 4. Let's check whether it's valid. Yes, we do get it as root 3 by 4. Right. So here we have limit of x root x minus m root m upon 1 minus x raised to 3 by 2 as x tends to infinity. So let's convert this to, so this will become x raised to 1 x raised to into root x turns out to be x raised to 3 by 2 minus m root m upon 1 minus x raised to 3 by 2. So the bigger power for the x is 3 by 2. So we divide by x raised to 3 by 2, which is x raised to 3 by 2 divided by x raised to 3 by 2 minus m root m divided by x raised to 3 by 2 divided by 1 upon x raised to 3 by 2 minus x raised to 3 by 2 divided by x raised to 3 by 2. Now, this will now become 1 minus m root m upon x raised to 3 by 2 upon 1 upon x raised to 3 by 2 minus 1. Now you need to find the limit of this. This is f of x. You need to find the limit of this as x tends to infinity. So this will turn out to be 1 minus is a constant, minus 0 upon 0 minus 1, which will turn out to be minus 1. So ultimately this particular limit turns out to be minus 1. And yes, we do get it as minus 1. Then further we have this particular thing, that is 1 cube plus 2 cube plus 3 cube plus x cube divided by x raised to 4 is equal to what? If x tends to infinity. If you look at 1 cube plus 2 cube plus 3 cube plus whatever 2x cube is nothing but sum of cubes of natural numbers. So this will turn out to be n into x plus 1 by 2 the whole square. Turns out to be x into x plus 1 by 2 the whole square. So this function itself turns out to be x into x plus 1 by 2 the whole square divided by x raised to 4. Which turns out to be x square into x plus 1 the whole square upon 4 into x raised to 4. Now, what can we do here? We can take 1 by 4, of course, common outside. X square by 1 of the x. So you get x square upon x square into x plus 1 the whole square upon x square. You split up the x square. This will turn out to be 1 by 4 into 1 into 1 x by, so this can be written as x plus 1 upon x the whole square. So this will be x by x, that is 1 plus 1 by x the whole square. Now if you take the limit as x tends to infinity, it turns out to be 1 by 4. So it is 1 by 4 into 1 by x. This turns out to be 0. So it's 1 by 4 into 1, which is just 1 by 4. So this particular limit is 1 by 4. So here we are using the sum of cubes of x natural numbers, that particular formula, and The answer turns out to be 1 by 4. Okay. Then you have limit as e raised to x plus 1 divided by e raised to x plus 2 as x tends to infinity is evaluated to be what? Now, you have the function as e raised to x plus 1 divided by e raised to x plus 2, and this function is divided. So we have as x tends to infinity. So again we divide by e raised to x, and hence you get 1 plus 1 upon e raised to x upon 1 plus 2 upon e raised to 1 plus 2 raised to e raised to x. So this is how the function turns out to be. Now we need to find the limit of this particular function as x tends to infinity. This will remain 1. As x tends to infinity, 1 by e raised to x will also turn to be 0, because again e raised to x will tend to become equal to infinity. So this becomes 0 upon 1 plus 2 into 1 by e raised to x. That also turns out to be 0, which will turn out to be 1. So hence the limit of this as x tends to infinity, 2 upon e raised to x. So I would like to explain this once again. E is an irrational number which is greater than 1. So as x becomes larger, as it becomes infinity, you get e raised to x also becomes larger and larger. So 1 by, as when x tends to infinity, e raised to x will also tend to infinity, and hence 1 upon e raised to x will tend to 0. So remember this part also. So you get 1 plus 1 by, so limit of this function, which turn out to be limit of 1, which is 1, plus limit of 1 by e raised to x, which is 0, divided by 1 plus limit of 2 upon e raised to x, which is also 0. So ultimately it is 1. So this limit is 1. Alright. Hence we get it that way. Right. Okay. Quite similar to that, we have this particular question. We have 2 plus e raised to x. So again you divide by 2 upon e raised to x plus e raised to x upon e raised to x. And here we have 7 upon e raised to x minus e raised to x upon e raised to x. And this function's limit has to be found out as x tends to infinity. Now this will tend to become 0 plus 1, and this will also tend to become 0 minus 1. So it's 1 upon minus 1, which is minus 1. So we're getting this limit as minus 1. Okay. Okay. Next we have limit of a minus bx divided by x square as x tends to infinity is equal to what? So it is a minus bx upon x square. So this will be written as a upon x square minus bx upon x square, which will be a upon x square minus b upon x. So you have to find the limit of this function as x tends to infinity. This will, of course, a by x square will tend to 0 minus 0. Hence the limit itself tends to 0. So we have it as 0. So in all these examples, we are saying that we see to it that the x term comes in the denominator, features in the denominator, so that particular expression can directly be substituted as 0. Alright, here we have a situation wherein you have root of 2x square plus 3 divided by 4x plus 1. Now this can be written as root of 2x square plus 3, and you have it has 4x plus 1, so you can divide both numerator and denominator by root x square, so which is the same as root of 2x square by x square plus 3 by x square. Now root x square is the same as dividing by x, so 4x by x plus 1 by x, which will turn out to be 2 plus 3 upon x square divided by 4 plus 1 by x. Now you need to find the limit of this expression as x tends to infinity, which would be root of 2 plus 0 divided by 4 plus 0, which is root 2 by 4. So we get root 2 by 4. Now among these answers we don't have it, but maybe we need to simplify it. Root 2 would remain as it is. 4 can be written as 2 root 2 into root 2. So this gets cancelled and you get 1 upon 2 root 2. So do we have that in the answer? Yes, we do have it as 1 upon 2 root 2. So you have to be careful over here, since the 4x plus 1 is not within the square root sign. You can divide this by x. Dividing the denominator by x is the same as dividing the numerator by root of x square. You are dividing by x, so root of x square is 1 and the same. So you get 1 upon 2 root 2. Right. Yes, we do have it that way. Okay. Now we have an interesting sum here. Evaluate limit of 2 plus 8 plus 18 plus dot 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 2n square divided by n cube, limit as n tends to infinity. Now what is this expression? If you see, you can take out 2 common in this and you get 1 plus 4 plus 9 plus n square divided by n cube, which will be 2 into 1 plus 2 square plus 3 square plus n square, the whole divided by n cube. Now if you see, this is nothing but sum of the squares of the first n terms, n natural numbers, which is going to be 2n into n plus 1 into 2n plus 1 upon 6 divided by n cube. So which will turn out to be 3, and hence you get 1 by 3 into n plus 1 into 2n plus 1 upon n cube can be written upon n upon n upon n. So this will turn out to be 1 by 3 into 1, n by n is 1, 1 plus 1 by n, 2n by n 2 plus 1 by n. So this is what the expression simplifies to. Now you need to find the limit of this particular function as function in n as n tends to infinity. This will turn out to be 1 by 3 into 1 plus 0 into 2 plus 0, which will turn out to be 2 by 3. 1 by 3 into 1 into 2, which is 2 by 3. So this particular limit's value is 2 by 3. And let's check whether we are getting it. Yes, we do have it that way. Okay. Now we have another interesting limit as n tends to infinity. Okay. So we have n plus 2 factorial plus n plus 1 factorial upon minus factorial. Now how do we do it? We can simplify this. We can write it as n plus 2 into n plus 1 factorial plus n plus 1 factorial. This will become n plus 2 into n plus 1 factorial minus n plus 1 factorial. In this numerator we can take out n plus 1 factorial common term and you get n plus 2 plus 1 inside. Again in the denominator you can take out n plus 1 factorial as a common term and you get n plus 2 minus 1. So this gets cancelled, of course. Gives you n plus 3 divided by n plus 1. Now we need to find the limit of this, so we need to divide by n, numerator and denominator. N by n is 1 plus 3 by n upon n by n 1 plus 1 by n. Sorry, 1 by n. We need to find the value of this. So limit of this function in n as n tends to infinity is 1 plus 0 upon 1 plus 0, because as n tends to infinity, 3 by n will tend to 0, which will turn out to be 1. So this particular limit is turning out to be 1. Right. So again, this is a different kind of a sum wherein we need to brush up our concepts of factorial, take out the factorial term common, and it gets cancelled. Yes, the answer is 1.